Hello, yes, welcome to JSM. In the previous lecture, we discussed Coulomb's law. In this lecture, we are going to discuss the properties of electric force between 2 point charges. Okay, see this already we discussed. Once again, we recall this. See, we have two charges separated by a distance r. They may be like charges or unlike charges. Okay, so the magnitude of electric force, that is, see here, F12. What is F12? Force on first charge due to second charge. What is F21? Force on second charge due to first charge, right? See, this will show some electric force on this one, and this also will show force on the second charge. Okay, so both are equal in magnitude and opposite in direction, which we discussed, and this is expression also already we discussed. Now let us see the properties of the electric force. So first one is that this electric force, so it is an action reaction pair. Action reaction pair. So what does it mean by? So means two charges. Okay, the charges which we are taking may be positive positive, negative negative, or positive negative, whatever it may be. Two charges exert equal and opposite force on each other. Opposite force on each other. Okay, so means, see, first charge is suppose showing 5 units of charge on the second charge. This second charge also shows 5 units of force, electric force on the first charge. Okay, so that's why it is the force is action reaction pair. Two charges exert equal and opposite force. Okay, the magnitude of force is the same, but they are opposite in direction. Okay, and the next one is that it is an inverse square law. Inverse square law of force. Okay, it is an inverse square law of force. See, from this relation we can say here the magnitude of electric force is inversely proportional to the square of the distance between the two charges which we are taking. Okay, see here, suppose if these two charges are close to each other, then they shows more force on each other. If they are far from each other, the force will be reduced. Okay, so here, for example, this distance, we are considering this distance as r. Suppose if the distance is doubled, okay, the distance between the two charges is doubled, what happens? The force decreases. How much it decreases? Suppose new force is equal to F by 4. Okay, means the force decreases by 4 times. If the distance is doubled, force decreases by 4 times, right? So old force, this is the new force after distance is doubled. Suppose if the distance is half of the original distance, okay, so the distance is half. Now what happens? The force increases by 4 times. Okay, the new force is 4 times to the initial force. Clear? So like this, the force, electric force is inversely proportional to the square of the distance between the two charges which we are considering. Now let us consider the very important property. The electric force depends on the medium in which the charges were placed. Okay, depends on the medium in which charges were placed. So just now we discussed the relation. Okay, so magnitude of electric force in the vacuum. Okay, so in the vacuum, what is the expression? 1 by 4 pi epsilon naught q1 q2 upon r square. This is the relation, right? Okay, so what is epsilon naught here? It is the permittivity of free space, right? Okay, so now suppose if a dielectric or insulator is placed in between these two charges, now what happens? The magnitude of force is changes. Okay, if a dielectric or insulator is placed in between two charges. Okay, if a dielectric is placed in between those two charges, now what happens? Let us say it as force in the medium. Okay, electric force in the medium. So that is 1 by 4 pi epsilon naught into K Q1 Q2 upon R square. Okay, so clear. So this is in the vacuum. This is the expression. This is expression for the magnitude of electric force in the medium. Okay, so here what is this K? This K is dielectric constant. Okay, K is dielectric constant and it is a dimensionless constant. Okay, the dielectric constant is a dimensionless constant. Okay, so here now see what is happening here when the charges are placed in a medium. So therefore the force decreases by K times, right? The force decreases by K times, yes or no? So here therefore here we can write a relation, that is force in the medium is equal to force in the vacuum. Okay, force in the vacuum upon K. Okay, so this is very simple relation. So what is we are saying here? The force is decreasing when these two are placed in a medium. Okay, so that is nothing but we can get by using this relation, right? Okay, force in the medium equal to force in the vacuum upon dielectric constant. Okay, and also here see from this relation here epsilon naught into K, that we can consider as epsilon. Okay, so what is this epsilon? So this epsilon is permittivity of medium. Okay, permittivity of medium. What is epsilon naught? Permittivity of free space. And what is epsilon? This is the permittivity of medium which we are considering. Okay, so therefore if we substitute this relation here, we get force in the medium. Okay, force in the medium is equal to 1 by 4 pi epsilon Q1 Q2 upon R square. Okay, so this is in the vacuum relation 1 by 4 pi epsilon naught Q1 Q2 upon R square. This is in the medium 1 by 4 pi epsilon Q1 Q2 upon R square. Very simple. See, in after completion of electric field concept, after that I will explain separately in a lecture the permittivity and relative permittivity. There I will explain everything in detail after finishing electric field concept. Okay, so here as of now, so what we have to understand here, the force, electric force depends on the medium in which the charges were placed. Now let us see the fourth property, very important, that is the principle of superposition of force. Suppose here we have two charges Q1 and Q2. Okay, so already we considered, so this what is happening here, this charge is showing some force on Q1, Q1 is showing some force on Q2, right? Okay, now suppose here we have another charge Q3. Okay, we have another charge Q3, then these two forces simultaneously exert some force on third charge. Okay, once again I am repeating, these two forces at a time shows some force on this Q3. Okay, so now what is the net force on Q3? That is nothing but the vector sum of two forces acting on third charge. Okay, so the net force on Q3, that is third charge, that is therefore we can write that is equal to net force on Q3 is the vector sum of two forces exerted by Q1 and Q2 on Q3. That is, see, force on third charge due to 1 plus force on third charge due to 2. Okay, clear? So this is a very important and very simple also. Just what we have to do, if we have three charges, two charges are simultaneously exerting some force on the third charge, then the net force on this charge is equal to the vector sum of the forces exerted by those two charges. Okay, clear? So suppose if we have n number of charges, okay, if we consider a system of n number of charges, not only three charges, in that case, see now, in a system of n charges, the net force on any charge is the vector sum of the forces due to all the remaining charges on that charge. Sir, no. Suppose here if you consider the net force on second charge, what is that? So the force on Q2 due to Q1 and also the force on Q2 due to Q3. So the vector sum of these two forces on Q2 will be the net force on Q2, like that. Okay. So therefore in general we can write, therefore net force on nth charge, okay, the net force on nth charge, that is F is equal to, we can write the vector sum of force on nth charge due to first charge plus force on nth charge due to second charge plus force on nth charge due to third charge and so on, plus force on nth charge due to n minus 1th charge. Okay, so this is the principle of superposition of force. Okay, see again this principle of superposition we discuss in the electric field concept also, very important. Okay, so very simple. If we have more than two charges, the net force on any one charge is simply equal to the vector sum of the forces exerted by remaining all other charges on the charge which we are considering. Clear? Okay, and one more thing here you should keep in your mind is that the force between these two charges that remains same. Okay, so here the force on Q2 due to Q1 is also present, force on Q1 due to Q2 is also present. At the same time here the net force on Q3 due to these two is the vector sum of these two forces. Clear? So okay, thank you for watching.